Now we move on to factors and multiples. So a factor is a number that divides into another number exactly without leaving any remainders. In other words, a number that is divisible by a number of interest. Okay, so what does that mean? So let's look at an example. What are the factors of 6? So the best way to approach in finding factors of a number is to divide the number by different numbers. Divide the number from 1 up to that number. Okay, it's easy for small numbers, but a bit tedious for larger numbers. Okay, but there are other tricks that you can do. But for GCSE level, if it's the first time you're seeing factors, approach it in this manner. So you do 6. So in this case, the number of interest is 6. So we start by dividing 6 by 1. So we do 6 divided by 1. Answer is 6. 6 divided by 2. The answer is 3. 6 divided by 3 is equal to 2. 6 divided by 4 is 3 over 2. Yeah, we can simplify this, or 1.5. 6 divided by 5 is 1.2. 6 divided by 6 is equal to 1. So we stop once we've reached 1. Okay, so now looking at these answers, we only take the whole number. Okay, we know the whole number. The number that does not leave any remainders. So notice here 6, 3, 2, and 6 divided by 6 is just 1. Okay, these numbers do not leave any remainders, whereas if you divide 6 by 4 and 6 by 5, you get 1.5, 1.2. So in other words, you have remainders or decimal numbers. Okay, so these are not factors of 6. So the factors are just 1, 2, 3, and 6. Okay? And multiples. What are multiples? Multiples are numbers. Multiples are number multiples, whole numbers, in a synchronous order. It is simply the multiplication table of that number. So for example, if you're asked to find the first 4 multiples of the number 9, the answer would be, so we do, 9 times 1, so the first 4 multiples, right? So it's 9 times 1 equals to 9, 9 times 2 equals 18, 9 times 3 equals 27, 9 times 4 equals 36. Therefore, the the first 4 multiples of number 9 are 9, 18, 27, and 36. Another important terminology, let's say, or term that we should add to our vocabulary, okay, is the term prime numbers, or terms prime numbers. Okay, prime numbers are extremely important in mathematics. So a prime number is any number that can be divided by itself and 1. So it has only 2 factors. One thing to keep in mind is that number 1 is not a prime number. And another important important note to remember is that 2 is the first prime number, and it is the only even prime number. All other prime numbers are odd. Okay, so 2 is the first prime number, and is the only even prime number. So we have an example. What are the first 10 prime numbers? So the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. You'll notice that there are no numbers. So all of these numbers, they only multiply by 1. They only have a factor of 1, basically. So basically, it's just 1 times 2 equals 2, 2 times 1 equals 2. Okay? there are no other two numbers when multiplied together give you this number, or give you any of these numbers. Okay, so these are all prime numbers. So prime factors. Prime factors, what are prime factors? Prime factors are any number that can be broken down into its prime factors. So to find prime factors of any number, it is best to do a prime factor tree. Okay, so what does that mean? So let's look at an example. It's best explained with an example. We have find the product of the prime factors of the number 36. In other words, break this number down to a set of numbers where you can't break it down any further. Okay, because if you remember, prime numbers, they only are a multiple of themselves, okay, and 1. Okay, so you can't, a prime number is the lowest you can go down to, okay, or a prime factor. Okay, so let's look at an example. So we have the number 36. Now, if number 36 is is in the first node, in the first circle, let's say, and we have 2 branches coming out of them. Now, in order to break this number down, now we know that this is an even number because the last number is 6, which is even. So the easiest thing to do is divide it by 2. So if we divide it by 2, 36 divided by 2, we get 18. Okay, so for 2 branches of 36, we have 18. Now we know that the number 2, you can't break it down any further. If you try to break it down, you'll get 2 times 1, right? So number 2 is it's in its lowest form, in its prime factor form. So we can't do anything with this. So let's color it and let's move on to the other branch, which is 18. Now, this number 18, notice that, okay, this is also an even number because the last digit is even. So let's do the same thing again. So as it's even, we know that we could divide it by 2. So 18 divided by 2 gives us 9. So we have 2 times 9 equals 18. Again, 2, we can't really divide any further, but the number 9, can we think of any factors or any 2 numbers that can any 2 numbers that multiply together to give the number 9? Well, how about 3? We need to do 3 times 3 is equal to 9. Now notice every branch of this tree is in its lowest form, like it's in its prime form, right? These are all prime numbers. We can't divide it any further. We can write it as 2 times 1, 2 times 1, 3 times 1, 3 times 1. Then we'll just repeat ourselves because the 3 will be again 3 times 1, so on and so forth. So we stop at the prime factors because we know that we can't divide this any further. Okay, so this is what's known as a prime factor tree. Now there are multiple ways of doing a prime factor tree, right? So here's another example. So let's say we didn't divide by 2, we divided by 4. So we know that 9 times 4 is equal to 36 also. What would we get? Would we get a different final answer? Well, let's see. So at this stage we have 9 and we have 4. So 9 times 4 equals 36. So we could work on either branch. So we branch them out. We know that 9 can be broken down to 3 times 3, and 4 can be broken down to 2 times 2. Now notice at this level we can't go down, break this down any further. Also notice that we have exactly the same answer as our previous tree. We have 2 times 2, 2, 2, 3, 3. Therefore, the product of these numbers, so that these are all prime factors, the product of all these prime factors is equal to 36. Okay? So we do 2 times 2 times 3 times 3 is equal to 36. In other words, the product of the prime factors of 36 are 2 times 2 2 to the power of 2 and 3 to the power of 2. Now, it is always good practice to show your answer in index form. So what that means is that the product of the prime factors of 36, as you saw before, was 2 times 2 times 3 times 3, which is equal to 36. Now, the answer in index form, not standard form, it should be index form, is 2 to the power of 2 times 3 to the power of 2, because we have two lots of 2 and we have 2 times 2 and we have 3 times 3, so we can write that in compact form or index form as 2 to the power of 2 times 3 to the power of 2. It looks much neater and it also produces the same answer. Okay, so as I mentioned, there are multiple prime factor trees we can do. Here's another possibility that we could have done. So we could have written as 36. We could have done, if we knew our timetables, we could do 6 times 6, which is also equal to 36. And from 6, we would break it down to 3 times 2 equals 6. 3 times and 2 times 3 equals 6. Notice that it does not change the final answer. So there are many variations we can do when it comes to prime factor tree. We should choose the easiest. It really helps if you know our timetables. But if not, just use the smallest number that's divisible. Okay, and just work your way down. It might take a bit longer. You might have a few more extra branches, but you will eventually get to the final answer. You get to the correct answer. Okay. So here are some questions for you to try. Have a go at them and see how you get on.